All right. Anyway, we will proceed now. So we are getting into the routing blocks. Let me give you one example. So this is home. You would have taken some connection, Wi-Fi connection for yourself. So that Wi-Fi connection would be connected to the service provider setup. That connection would go to another service provider, another region or something. You have the submarine cables, and on other side you might have various other service provider, and finally it will reach the end destination, which could be Facebook. Let's say you're accessing something else, Twitter. Maybe you're using up your service, it goes to ISP. Then might be the Twitter is located on a different region, so it goes to ISP, it goes to ISP, it goes to ISP, and then the Twitter head office or data center is located. So on. Let's say you are connecting to any gaming website or PUBG or anything, gaming website or whatever. So you take to your ISP, the ISP might push it to the next ISP, that will push it to another ISP. There could be submarine cables connect to ISP, and then you reach it to the gaming server. So you will see that your ISP is your gateway. You may not know how to reach the end destination, but what you're trying to do, whatever you're browsing on your web browser, when you type www.facebook.com, basically it goes to the service provider and service provider will take it forward. If you type www.google.com, it will go to the service provider will push it. Okay. So while you do this push, there are certain networking components that is used. Okay. So let's take that these are routers, the networking component routers. So wherever you see the ISP mark, they are routers. So basically the router should know how to reach the destination, or router will do the concept of routing the packet from where to where, from source to the destination. From source to destination, your packets are getting routed. So this could be your home location, and this could be any remote location, wherever the destination you are trying to hit up. So there are certain things that you need to understand while this flow happens. So let's assume that to reach Facebook, there might have been another path. Okay, ISP and ISP. Now you have two best path. So now this router, it will decide whether to take this one or to take this path. So here you see that it's only two hops. Hops are nothing but the intermediate routers or the intermediate path that depends. So here you see that's only two, 1 and 2. Whereas if you see here, it's 1, 2, and 3. So remember that routing table will only have one best route inserted. So in the routing table, if you check the route to reach Facebook, there will be only one best route. So there should be some tiebreaker. tiebreaker in the sense, what is better? In this case, we have the hops. We can say that 2 is the shortest path. Always remember, routing will consider the shortest path. Shortest in the sense which is close enough to reach. So of course the 2 hops will be the closest one. But the next one, it's not considered as a bad route, but it can be considered as a backup route. So for some reason, if one of the ISP is down due to some fiber cut or something, so what router does, it will remove this 2 hops and bring up this in the routing table, the standby thing. So there will be always one in the routing table, and this is what the router would do. Router will know the best path and the standby path. If the best path for some reason goes down, then it will have a backup path to reach them. Okay, so when it comes to routing, what are different types that we have? We have a static route. I have something called as dynamic routing, which are RIP, EIGRP, OSPF, and then there is something called as exterior gateway protocol, which is BGP. So these are the dynamic routing protocol, IGP, interior gateway protocol, and this is called as EGP, exterior gateway protocol. Now this both are used especially in the LAN premises, whereas the third one, the last one, the BGP, border gateway protocol, that is used in the WAN side. Okay, local area network, wide area network. Where is that wide area network used? These are your WAN network. WAN network. This is a WAN network. This is a WAN network. This is a WAN. This is a wide area. This is a WAN network. These are WAN, which are connecting between 2 ISPs, are considered as WAN. Then what is LAN? LAN could be within your house. Might be you have a gaming workstation, you have Xbox, you have a smart TV. Let's say you also have a hostel facility or PG facility on your top of your house or something, which consists of 3 to 4 floors. So you don't need to buy a ISP connection for each floor, right? You will take only one connection and then you just distribute them to others. So now this is your LAN premises. They all will take this connection to go out. Okay, so within that you have LAN, and in order to have the routing between them, you will use one of this. You can use static route, RIP, EIGRP, or OSPF. Whereas in the WAN side, you have the BGP, exterior protocol. So this BGP is, wherever you see WAN, BGP, you should think about BGP, that BGP is making the routing decision. So these are all BGP protocols everywhere. Okay. Whereas in the LAN side, you have this option. Starting with static route, RIP, EIGRP, OSPF. Now we will talk about why so many things. Let's say in the static route, if it is just between me, my computer, and my gaming workstation inside a LAN premise, I have a IP address concept. Let's say behind that I have some more gadget, or let's say there is a switch here, and the switch is connected to multiple devices in the local area network. So if I have to read something, I can just say that to reach the destination IP with whatever gateway or whatever, I can go with the gateway IP. Okay. So this sort of commands I can keep in the router where I am telling it manually. These are manually written. It's manually written. My destination is my whatever gadget. It's like Xbox, smart TV. Okay. Gateway is nothing but, let's say it's my internet modem or router, which I'm using at the home. So I'm just telling that to reach this device, go via this. To reach this device, go via this. But it's manually written. The problem of having manual in the enterprises, you might have a lot of users there. If it is one or two or three or four, you can still go with the static routing. But when the number of users are in a large quantity, you cannot spend time to write this manual, because what happens is, let's assume that in this scenario, this ISP, he might have its LAN infrastructure. Okay. And the backend of this, he's having a LAN infrastructure. Employees are logging in, log out, lot of internal portals would be used, etc., etc. So you cannot think of writing a manual static rules, because if that is the case, then you have to apply them in all the devices. You have to put the routes in all the devices. Say, for example, in a LAN environment, you have 4 routers. Okay. And you want to reach this guy. So let's say you put a static route to reach this, go via this. The same manual route you should also put across on this. You can say to reach that, go via this, you will reach it, or go via this, and go via this. Same goes with on this side. You will say that you can reach via this because this is the shortest method instead of that. So this is all done manually on all the 3 to 4 routers. If you have many more routers, you will spend unwanted time on writing the manual thing. That is why we bring up the concept of dynamic. So in dynamic, what happens? We just enable them. I will enable the IGP protocol between these two. So there is a mechanism which runs automatically. They will form the neighbors. Okay. If this router will see that other router is sending some hello packet, this is also gonna send some hello packet. They will go under some stages and form a neighborship. So what is the benefit of neighborship? It will tell all its prefix to this guy. Now this guy's routing table keep on increasing. Now it knows what is my neighbor, and my neighbor's neighbor also this guy is gonna know. Same goes with this person. He will distribute his prefixes or his network, as well as he is interested to know about the rest of the people. So at the end, the routers will have all the knowledge about all the different router who is connected to whom. Okay, who is the neighbor to me, and plus who is that neighbor's neighbor. It will know that. Now what happens? Auto calculation starts. Instead of you defining manually, auto calculation start to reach this U. How should I go it? Should I go via this direction? Should I go via this direction? If they are both equivalent, then both will come inside the routing table. Okay, both will say to reach this destination, I can go via this or I can go via this. If there is some changes, let's say one path is on the Giga Ethernet, which supports 1 gigabits per second, whereas the second route is over on the Ethernet medium, which supports only 2 to 4 Mbps. So definitely the auto calculation will say, let me take the gig interface. So the gig interface path will be considered in the routing table, not the Ethernet. Ethernet will be discarded and might be it can be kept in the backup only. Okay, now this is a auto calculation. So that is what is preferred in the enterprise. We don't add the static route. A static route is added only when there is one server in some corner, and I just want to point it. I will say that to go to that, go via this. Might be only one user is trying to connect, so I will just add it. If there are more number of users who needs it, and you need this to be added on multiple devices, then don't ever think about static routing, because then you have to add this route in multiple places. Instead of that, you can advertise that particular network in the routing protocol itself. So at the end, to reach that, they will auto calculate it, and they will find it the best shortest path to reach that. Okay. So that is a dynamic IGP or dynamic protocol. Whereas in the exterior BGP condition, we define our neighbors, because this is a WAN site. If I put dynamic instead, in case of WAN, there will be too many noise. Why? Because you can just think in this case itself, the neighbors are forming. There could be some timers, there could be some authentication packet. If one goes down, the backup comes up. There are so many things happening in the dynamic thing. They are very aggressive sort of protocol in the LAN side. But in the WAN side, you know that there are millions of routes, millions of website, millions of hosting spaces, millions of applications. So there are millions of routes in the internet. So if you put the dynamic protocol, there will be so much of noise that there would be collision, there would be the packet getting discarded. So what we do in the BGP side is we put or we decide our neighbors. Okay, so let's say if this is the source and this is the destination. So to reach the destination, I have certain paths. Let's say I have to reach this. So between this, I will form a neighbors. Now this is a selective neighbors. I will just ask my service provider or internet service provider to provide me a public IP. So let's say he is giving me some public IP in this range. /30, and he himself becomes 2.1.1.1.1/30. So I'll configure BGP between that. Okay, that is what my concern is, to create a BGP. What about that ISP will do? ISP will have all the rest of the connection. So he might have done the BGP with the next service provider. Those people will have a BGP to the next service provider, and so on. It reaches till here. Okay. So in the BGP, we will only advertise what is required. We will not advertise all our LAN traffic. We will not advertise the private IP at all. We will just try to advertise the public IPs only. So this is where the BGP neighbors will form. If anything goes down, you should log into the router. You should hit some commands like show IP BGP neighbor. It will reveal you what is down, what is up, etc. And accordingly, you can log a ticket with the service provider that this ISP is down or this link is down. So for you have to raise a ticket, and then they will check in the backend if there is something down. So they will give you the root cause as well. That link between, let's say, Australia and Africa is down, okay, which is under repair or something. So they will give you some root cause as well. The issue is not needed to be on your side, on the destination side, or the directly connected service provider. It could be anywhere intermediately as well. So this is where these protocols sit properly: static route, dynamic IGP, and EGP. There are certain other protocol, but we don't use in these enterprise level. There is something called ISIS. It is equivalent to OSPF. Okay, but where it is used in the ISP side, service provider side. Instead of OSPF, ISIS is used. Apart from that, there is no other protocol. So let me show you one router. How do you check the routing protocol and what are the different commands? So boot up one of the router. Okay. So if you want to see the routing table, this is the command show IP route. So when you see this show IP route, you get the output of this. There are certain information that they have provided. It says code. So if you see L, that means they are locally originated route. That means 1.25 is a interface on this router. 1.70 is a interface on this. 1.97 is a interface on this. How do I check? I can just make use of show IP int brief. See, 25, 70, 97. They are locally originated routes. If you see the uppercase C which says connected, because these are all directly connected. So whatever network is associated 192.168.0/26, that's directly connected. Okay, so for that you just open this interface. You will get to see show run interface, paste it, gig 0/0, enter. See, this is the network that you are advertising. 1.25/26. So you see here, this is the network /26. For the second connected, you see it is 1.64/27. Then 1/1.96/29. So you remember this we configured in the VLSM config. We created one VLSM block, we created second VLSM block, and we created third VLSM block. And that we advertised in the routing configuration. So whatever you do it, now it's visible in the routing table. We have not built any so far any routing. So we will not see any static over there or RIP or BGP or EIGRP. I will not see it. But these are some of the protocols: static, RIP, mobile, BGP. We don't use all those things. Okay. EIGRP, EIGRP external, OSPF inter area. Now this is a part of OSPF itself, inter area, NSSA external, type 1, type 2, E1. So these are all part of OSPF, different flavors. This is ISIS protocol, which I was telling in the service provider side. This is ISIS. These are all IS related. Okay. So these are just a code for your reference, because if you check something like L, you should refer it over here. If you see something as B, you can refer it, what B would stand for. So this is the important block. You need to understand what this block is about. Gateway of last resort is not set. Basically, this is where you set the next gateway hop. You can set one default gateway. What is the benefit of setting this default gateway is, if for some reason you receive some traffic, okay, not in this range, what is the router gonna do? Router is gonna drop them. But if you keep a last gateway resort, so basically you are telling that not to drop at this point. Instead, you are sending it to the next person or the next router. Might be that router will know the route towards that. So for example, you are over here, you have a users who are trying to reach to you. So within this routing table, you see something as gateway resort not set. But if you set that, you're basically pushing it to the next device. Let's say this device is 1.1.1. So you can set that gateway resort to 1.1.1.1. So what happens is we are not discarding at this point, or we are not dropping at this point. Instead, we are still sending it to the next person. The next person might know how to reach that destination. Okay. Might be this is your main server or something, which is exposed to lot of destinations. So something like this, we can set a gateway instead of dropping. If you don't set this, if this is not set, you receive some unknown traffic. And if the gateway is not set, it will just be dropped at this point itself. So just to avoid that, we keep a gateway. And so this is gateway. Now, if you see here, these are called the routing protocol code. This is code. Okay, the codes are being self-explanatory. This is the network that you are calling. So it says that this network is directly connected on this. This is nothing but your own interface. So if you just elaborate this using show run interface ID, you will see the network being utilized there. It says that it's local. Local is nothing but the interface IP of that interface. It says that this is directly connected over on this. Same way, you can see this is directly connected. The network is directly connected, and this is the local IP address which is over on this interface. So just to see them, you can take the interface ID. You can go with show run interface and paste that interface ID. So it will show you the complete configuration. You can see that it was a geo link. This is the block 1.97.248. See. Okay. So the routing table by default will give you all this information. Also, when you see this CIDR representation, it's also called a prefix length. Okay. Prefix length is nothing but what network are you advertising. Sometimes you would like to advertise some network. Say, for example, this is a router. This is a switch. Behind a switch, you have different users sitting. You have a sales guy. You have a marketing guy. Sales guy is located on this IP. And marketing guy is located at this. So he is on VLAN 10 and he is on VLAN 20. Now router is connected to another switch, and on another switch you will see lot of sales people sitting. No marketing people. So you will configure VLAN 10, VLAN 10. These are, let's say, 192.168 1.10. This is 192.168 1.20/24. So this router is acting as an intermediate person. For some reason, if the sales guy wants to talk to the sales guy sitting in a different floor. So what this router needs to do, router needs to advertise the network. He needs to advertise his 192.168 1 dot, so that the different floor people know that there is someone on the different floor. So while he advertise, he will advertise from which interface ID that's been read up, or what is the information. So if you see here, it will give you some information that to reach so and so go via this, to reach so and so go via this. Okay. So you are advertising it. Same time, let's say you don't want to advertise this, then you don't include it. Don't include it. So the other people will also not know how to reach about this guy. So depending upon what you want to promote, we have to advertise it. So while we advertise, I will say 192.168 1.0/24 user need to be advertised. So this router or this information will be passed on here so that they know how to reach this particular user. So prefix you will see, and network mask, if I have something for so and so, what is the mask for it. Okay. Same way, if you have /26, /27, you know how to calculate them using the binary, and then you calculate it. Okay. And I believe the next hop is also clear. What do you mean by next hop? Is it basically the IP of the next device. So let's say there is a user here, and if a user from this side wants to reach this, so on the router, I will say to reach that destination, whatever destination it is, to reach that destination located at this mask, go via the next hop. So this is acting as the next hop gateway. So you can tell that in a IP format, you can say 211.1.1.2, which is nothing but this ID. Or instead of instead of IP address, you can also define which interface you are exiting. So you can say that it is to go via so and so. So there are two ways to define a static route. You can say destination, the mask of it, and the IP address of the router, the gateway router, or destination, mask, and the self interface ID from where the packet has to go out. So these are two ways you can define the static route. Okay, you can go with any way instead of yes. So Sudhakar, that we do via ACL process, access list process, that if one team don't want to talk to other or vice versa, that is done via the ACL. Okay, and let me bring a concept of administrative distance. And let me tell you in what circumstances this is used. Let's say this is source. This is destination. So you have one router, this is another router. To reach that, might be you have three different paths. Okay. This is R1, R2, R3, R4, and R5. You also have different protocols advertising them. You have RIP, you have OSPF, you have EIGRP. Okay. Similar way, you have RIP, you have OSPF, EIGRP. So there are three possible routes to reach the destination. Now, what routing table will gonna have it? Because you know that the routing table will include only one best path. So on what basis that is considered? So there are three factors. Okay. One is called the shortest or the smallest prefix list. The smaller the prefix list, the better to take it. The second is the administrative distance, AD value. And the third is the cost. Cost is also called as metric. So let me tell you what does the first method say. First method is about if your reaching this destination, which is located at 192.168.1.100. Okay. So the first router will see that particular network advertised via RIP in this range. Okay, 192.168.0.0/16. Whereas EIGRP, let's assume it's advertised 192.168 1.0/24. And in the case of OSPF, it is 192.168 1.100/32. Okay, so let me put it here. On the RIP protocol, you have advertised a very broad network. In the EIGRP method, you have used bit OK. You have advertised it in a class C. And in the OSPF protocol, you have been very particular about those IP itself. Okay. So now, ignoring the rest of the factors of a protocol, this is your first preference to decide which way to take it. And as per the configuration, this is the best. I'm not gonna check whether it's OSPF or RIP or EIGRP. I'm only gonna check the smaller prefix list. So the more particular you are about that destination, that wins the election. So here, when you say 192.168.1.100, which is a specific IP, I didn't say that 192.168.1.0/24, right? I didn't talk about a network. I am talking about a single PC. So the PC is on /32. So out of the three path, my OSPF protocol is having the most what do you say, the smallest, or the I can say this is also called as longest match. How is the longest match counted? You need to expand it up. So let's say if I have 192.168.0.0/16, so you need to put them in a binary format. So you have 192.168 1.0/24, 192.168 1.100/32. So you need to put this IP in a binary format. So let me take the binary of IPv4. How to convert binary to decimal? Okay, I need decimal to binary. Sorry, decimal to binary. One 192.168.0.0. Okay, I'll say that IPv4 to binary. Okay, I think this will work. Yeah, so now if I put 192.168.0.0, this is my binary method. Okay, so let me take it in a notepad. So out of the three, 192.168.0.0/16, I take the binary format of it. Similar way for 192.168 1.100/24. This is a, let's say, network as 0 and let me convert it. You get this. And for the very last one, when you had the IP called directly 1.100. So in this case, you need to check what is having the longest match with respective to the IP. If you have 192 as your destination IP, which should be, let's assume this. Okay. So which one is almost relevant to that? See, if till this one, it's relevant till this one. After that, you see that is different. It has one on the last octet or the last bit. If you check the second one, let's see how long it goes. It goes till here, bit more than the top one. So /24 is better than 16. But if you see the /32, it's a good match, the longest one. So the longest match wins the election. Or you can think in this way as well. Wherever you declared the highest CIDR value, you have 16, 24, 32. 32 will be the highest CIDR value that will win the election. The second best would be 24 and the third best would be 16. Similar way, I'll give you one more example. The IP is meant to be 172.16.0.10, but you have route number 1 to be 172.16.0.0/12, route 2 172.16.0.0/18, route, okay, it's route, not router, okay, route 3 172.16.0.0/26. You need to elaborate this. So let's say if I elaborate the IP in terms of binary, because it's called longest match. Let's see the IP address. Let's see the binary format of it. Let's keep it here. Let me find the binary for the one with 12 CIDR. So this is the one. I keep it here. I take the /18. See, we already know what is gonna win. The highest CIDR win, because that is more specific or particular with the IP. But I'm still showing the theory behind longest match. How in terms of longest, why do we call it a longest match? And this is the last one, which I keep it here. So from this method, the first factor that it checks to see the route, if there were 3 routes, is the longest match. So we are reading about the longest one, longest match, LM. Now let's compare this with the 3 of them. See, this is okay. One thing I did. Okay, let me take it because these are in a network mask, so I will take it the complete conversion. Okay, I'll better take some IP changes. So if I take only for this, what will happen? All the 3 result will look the same. So what I will do is I'll just change. Let's say I'll put something here and /26 is above /24. So let's make some changes here. Okay, this is done. Let me take this. Okay, so if you compare this with this, okay, so if you compare this with 12, so 12 comes to be 8 and over here. Okay, if you have 18 with you, which would come somewhere till here. When you have 26, the match is more. Number of matches more. So which is treated as the best route? If we have three routes, we will see which is having the longest match. This, let's say this is giving 26, this is giving 18, and this is giving 12. So the longest match win, or you just see whatever CIDR value is a highest CIDR value. So in our case, if I have three routes, 192/16/32 and /24. So from my longest match perspective, the one with this will win. It will win the election. And in the routing table, over here, the routing table, you will see the decision. You will see that the path number 2 is considered as the best match. And the rest two are kept in the standby. But sometimes what happens is, whatever you advertised remains the same. You have three protocols: source, destination. You will see the same advertisement. 192.168.1.100/24, 192.168.1.100/24. Now this is via RIP, this is via OSPF, this is via EIGR. Definitely now your longest match is a tie. Okay, it's a tie. You cannot decide because they are advertising the same network. So the tiebreaker is AD value, which is called administrative value. This you need to remember for the major protocols. What are the admin value for them? So let's assume that if it says connected, that means it's more reliable, more trustful. So the value is 0. If it is a static connection, static in the sense I define to reach that, go via this, that is also trustful. If it is a BGP, you know that in BGP, I told you that we define them manually. So that is also more trustful. But in the case of other protocol, which are dynamic, we don't define the neighbors manually. So they cannot be trusted. So in terms of that, we have EIGRP configured with 90, OSPF with 110, and RIP with 120. So if you check the AD now, AD factor, RIP has AD 120, this is 110, and EIGRP is 90. So in this case, who wins? EIGRP will win, which is nothing but path 3 will win. Similar way, let's assume that if these are not three different protocols, they are all same protocol, OSPF, OSPF, and final OSPF. So LM is a tie, AD is a tie. Now you need a tiebreaker, which is metric or cost. Now that can depend on the different path that is used. Let's say you are having Ethernet medium. These are Ethernet medium, whereas this is a fast Ethernet medium, 100 Mbps, whereas this is gig interface. So if your path will take this, might be the cost is 200. If you take this path, might be the cost is 50. If you take this path, might be the cost is 10. So the smaller cost wins. So in this case, EIGRP will take up because of the shortest metric. It's nothing but how much cost you give it to travel to the destination. So if it is a smaller, you prefer going with that. So these are the three routing path selection decision maker. Okay. So in the case of LM, highest win. Okay, the highest CIDR win. In the case of AD, smallest win. A smaller AD is a more trustful. And in the case of metric, it's again the smallest win. But now what happens if all the three paths are same cost? And in what case that will happen? You are using OSPF all the three scenario. You are making use of fast Ethernet on all the interface. You are advertising all the same prefix length. So your longest match is a tie now because you are advertising /24. The AD value is a tie because you are having OSPF on all the three paths. Cost is same because you are making use of fast Ethernet. So whatever cost you find it on this side, let's say it is 1 and 1. So total is 2. So you have 1 and 1, it's total 2. So basically it's same cost. So in this case, this router will keep all the three paths to reach the destination. It will look like to go via to that destination, you have path 1 available, you have path 2 available, and you have path 3 available. This is called concept of load balancing. Okay, equal path load balancing. Equal path load balancing. Now OSPF supports that. OSPF is a protocol which supports equal path load balancing. So if one route went via this, so the next would go via this, third will go via this. Again, the fourth would go via this, fifth will go via this, sixth will go via this, seventh via this, eighth, ninth. So basically all the three paths are now stored in the routing table as a best path to reach. So you got the flow, how the router decide what are the three factors. So in the CCNA, in the latest CCNA syllabus, we will see the static. I'll show the EIGRP and OSPF and BGP. But to be frank, in your curriculum, only OSPF and only OSPF is provided. Basic on OSPF is being expected. Whereas when you go to the CCNP level, then you will have EIGRP, OSPF, BGP, and static, along with redistribution. RIP is not used. This is not used anywhere. Neither you expect any question in the certification, neither in the interview. Okay. So this is a outdated protocol now. So in the CCNA, it's only OSPF. But when you go to the higher certification, you will see many more. So I'll just give you the brief. I will not go in depth of what is not required. But I'll do one lab to show you how the neighbors are built and what are the different packets. We can check some more detail for OSPF. So this was a introduction for routing. Tomorrow's agenda is we talk about the three protocols: EIGRP, OSPF, BGP. We do some comparison. Okay, we can also do a comparison between EIGRP versus OSPF. This is something which is asked in the interview, or you can also do a comparison between IGP versus EGP. Okay, so these are some questions that's been asked in a interview scenarios. Yes, guys, any doubt? Have you understood the concept today? Yes, no. Yes, guys, I can see from Sudhakar. What about other? Okay, need to see recording again. All right. What about Aditya, Christo, Tarun? We have someone else, but I don't know.
Yeah, yeah, Sagar, I think I need to look into the recording again, why? Because this is my first session.
Okay. All right. All right, guys. So recording will be available in a shorter span of time in the web portal itself. You can go through it once more before we connect in the next class. All right. Have a nice day. We'll connect tomorrow. Take care. Thank you.